The average temperature on the planet grows steadily. It's widely thought that we, the people, are responsible for it. Industry-related greenhouse gases disrupt natural balance. Plants and transport pollute the atmosphere with CO2. It creates the greenhouse effect, and the atmosphere is getting warmer. It's considered to be the main reason of global warming. What if we stop emitting CO2? Is it going to cool down? It's not that simple. The warmer the atmosphere is, the more CO2 it can contain. The more CO2 gets to the atmosphere, the warmer it gets. It's likely that we started this. Humanity made a necessary impetus, but the catastrophe will continue by itself. Like a rolling snowball, oceans will get bigger and attack the ground. The areas which won't be hit by water floods will be flooded with refugees. People won't have enough water and food. Civil wars will be starting here and there. If the temperature rises 2 more degrees, 300 million people will be under attack by the weather. 1 degree more, and the number of victims become 3 billion. We can easily compare global warming with a flu. 38.6 is unpleasant, but it's not life-threatening. And what if it gets 39.6 and higher? It's like the climax of a disease. Here, the virus either dies or kills. Could it possibly be that our civilization is like a fatal malady for the planet? Aren't we like viruses? If so, the crisis will pass, the temperature will get normal again. But will there be humans on Earth? It is proven that the global ocean rise speeds up. Compared to 1900, now its level is higher by 20 centimeters. Almost 10 centimeters is the distance which the water has covered in recent 20 years. This process is uneven. In some places, the sea level hasn't increased critical marks, but there are spots on the map where the ocean level has already risen by 25 centimeters. When it reaches a meter mark, some people will have a chance to enjoy a closer beach, while the others will suffer floods. Where will they go when they lose their houses, fields, and pastures? There are small island nations in the Indian and the Pacific Ocean. Once they understood that the sea level would definitely rise by 1.5 meters, their governments went hysterical about that. It just came to their mind that their islands could disappear. The Maldives are the first on the list. 1,200 beautiful lagoon islands are located just 1 meter above sea level. Scientists say it will take around 50 years for this land to disappear. Let's take 2 countries, Bangladesh and the Netherlands. Both of them suffer from floods as these lands are low. Obviously, the Dutch have better chances to protect themselves from climate change, and we don't know what will happen with Bangladesh. Its population is huge. Millions can die, and this is a great problem. According to the forecast of the Worldwide Fund for Nature, not only the Netherlands and Bangladesh can go under the sea in 100 years, St. Petersburg is under the same risks. The reason is simple. It's getting warmer in Russia, warmer than anywhere else on Earth. Every 10 years, the atmospheric temperature rises by 0.17 degrees. It's an average. But in Russia, it's 0.42. It's from 2 to 2.5 times faster. We're on a huge continent. Its thermal capacity is much less than of the ocean. Energy input for the ocean's heating is bigger in numbers. That is why our land is getting warmer faster. Russian climate has already passed the global point of no return. The temperature has risen by more than 2 degrees from the start of the technological revolution. This figure says no more than the average temperature of the patient at a hospital. While tropical islands are facing the coming Armageddon, the severe climate of frozen Russian lands is getting normal. Well, as you see, what is bad for them is not so bad for us. Russia has the advantage of fuel economy. Every year we consume around 100 tons less, as we don't need to spend so much fuel on heating anymore. Warm periods last longer now. In 40 to 50 years, it will be possible to grow oat in Arkhangelsk, and we can hope for high yield. In West Siberia, you cannot plant fruit trees, just potato and cabbage maybe. In the future, it will likely become possible. It's also possible that the Northern Sea route will become free of ice for most of the year, and it will freeze only in winter. Then this route is sure to become more popular, as it takes 2 weeks less to go by north than to take a more common route through the Suez Canal. Russian ports and trade companies will benefit from this situation and will provide the necessary impetus to the northern territories. The main problem is that everything which is happening to our climate is the result of the natural process, and we cannot affect it. We apply no efforts for it to happen. However, we need to apply much effort if we want to use the benefits of this situation. Russia will have to invest huge sums of money in various economic sectors. Now we have many problems on those territories, and these problems will never solve themselves. No one bears the responsibility for the accuracy of weather forecasts if they were made decades ago. Modern science still cannot predict the weather for the next year. There is no use asking for a precise forecast of the air temperature in spring if it is autumn. You cannot predict water level in the rivers as well. There are borders for scientific knowledge, and there are the problems which lie outside those borders. In the nearest future, we won't learn to forecast for more than a week. It's not a local Russian problem, it's the same for the whole world. People all around the world are worried about climate change, but climate is just the statistics of weather, and it turns out that we still cannot make a breakthrough in forecasts. Many researchers contradict with the UN, saying that there is no human's fault in what's happening with the planet. There are cycles in nature, and they totally depend on the situation in space, solar activity, orbital oscillations, the inclination of Earth. Everybody seems to be sure that we are living in the period of global warming, but in 100 years it may turn into another ice age. People cannot affect such global processes. Our role is relatively small. Our planet has survived hotter times. The Laman-Suo swamp is 7,000 years old. It emerged here due to the global warming process. The water of the ancient glacier is buried at the depth of 12 meters, somewhere on the bottom of one of these relict lakes. 10,000 years ago, this land was covered by sea. The great ice melt raised the sea level by 100 meters, and continents acquired their modern shapes. Woolly mammoths became extinct. Humanity, on the contrary, came to the age of its prime. Here is the story from the recent past. It happened less than 400 years ago. In 1618, Russian sailors made an outstanding achievement. They sailed around the most northerly point of Eurasia, Cape Chelyuskin. The researchers found proof of that event in 1941. No one had ever sailed that route before, and it remained unavailable for more than 250 years. Only in 1878, a Norwegian expedition went there on a ship called Vega. They traveled almost along the whole Northeast Passage to Chukchi Peninsula. It became possible because the weather was abnormally warm that year. Nowadays, you cannot go this route without an icebreaker. Does it mean that it was warmer in 1618 and then 250 years later than it is now? We call this global warming a unique event, but what if it's just because we don't have enough knowledge? St. Petersburg Main Geophysical Observatory. This place is the storage of Russian Empire's weather statistics for the last 300 years. It was 1872 when they issued first all-Russian weather map. It was the official start of the weather service. The map was simple. It included the plots of pressure and wind vectors. They started with 27 weather stations, and they ended the year with 55 of them. Hundreds of inspectors in different offices of the observatory would send the weather data to St. Petersburg. Famous scientists like Mendeleev and Kurchatov took part in the survey as volunteers. Ilya Ulyanov, the father of Vladimir Lenin, also took part, as well as this historical character. It says, Senior Measure Zhugashvili, 1900. It was the real name of Joseph Stalin. He used to process weather tables and charts in the Caucasus. Look, it's his original handwriting. Abral Dorso, Chernomorsk area, May 1900. There are records about catastrophic heat waves, droughts, floods, severe frosts, but there are no calculations which would show a stable trend. The researchers haven't registered the cycles of climate changes. That is why it is so difficult to predict natural anomalies. You cannot have a look at the past and say something like, it happened once 200 years ago, and now it's going to happen again. Here, in the museum of the main geophysical observatory, we finally found the name of a person who knew that the climate's character was cyclical. He would often use that knowledge for making long-period forecasts. It's not another legend. That man used to live in Gornaya Shoria. His name was Anatoly Dyakov. In Siberia and Altai, people called him the weather god. Fyodorov, the head of the weather service, invited him to Moscow. He had to, because the officials had heard something about the weather god from Altai. They were surprised to hear he didn't work in Moscow labs. Papers and magazines interviewed Dyakov. He became a star. They asked him to write a manual on his methods. He was offered an apartment and his own laboratory to improve the method. He refused. Dyakov didn't share his unique approach with anyone. He said he didn't need the laboratory and refused to compile the manual, so soon he was gone to Altai again. Timur Tau, Gornaya Shoria. Here is where Anatoly Dyakov lived. Here, almost 50 years ago, he made his famous forecast. This is his personal observatory. Anatoly Dyakov built it in 1968. He spent the last years of his life here. Every day he would wait here for the sunrise. Every single day he would make solar sketch maps. Dyakov was deported from Moscow to Altai in 1936. By that time, he had a degree from Odessa University in astronomy and was about to get a degree from Moscow State University in physics and math. He was well educated. He could speak fluent French, could boast perfect memory and observation skills. Maybe his quick eye led him to mines. There he started making forecasts. It was the beginning of the great duty which he carried out till the very last day of his life. Today, Dyakov's observatory on the Ulu Dog Mountain lies in ruins. I've been here several times. I remember the first time as if it was yesterday. August 5th, 1979. I was approaching Timur Tau and asked the driver, "Where does Dyakov live?" "You mean the weather god?" said he. "Yes, the weather god." And he showed me this place. From the 1960s to the middle 1980s, Siberian farmers didn't start sowing season until Dyakov allowed them. In his forecast, he could predict early spring or late fall, droughts and floods. He would send the information directly to local authorities. After that, the forecasts were sent to farms. Hydrometeorological Center also issued weather forecasts regularly, but they were not that accurate. I don't remember the exact figures, but his predictions were the most precise of all. Those who worked with him know that it's true. Dyakov's forecast helped save crops for years. In 1972, he was awarded with the Order of the Red Banner of Labor. The official note said, for successful increase in oats production. Dyakov took offense. He had been longing for the acknowledgement of his science, but those were not the words he had hoped for. Okay, let me show you the sun. We'll see if there are any spots. Heliometeorology, that's how Dyakov called his science. He studied the correlation between the scale of sunspots and atmospheric processes. In such a way, he determined the cyclical weather changes depending on the sun. He marked the spots and compared them with these templates. Being a physicist and an astronomer, Dyakov proved that atmospheric pressure change was not the key parameter for forecast, while airstreams affected by the sun and terrestrial magnetism means a lot. Yes, he made a lot of forecasts, but I cannot check them. He never published his works. He sent all the data to the authorities. We don't have it, so we cannot verify it. They say that his forecasts were precise. We still cannot predict weather from sunspots, and we don't know how it can be done. The researchers of the Institute of Terrestrial Magnetism admit that even modern technology and long-term observations of solar activity don't help define the cycles. Nature is not that simple. We don't have the method which could help us predict climate changes in the nearest 200 years, for example, on the basis of solar observations only. So, questions still arise. 1893. English astronomer Walter Maunder, a researcher at the Royal Greenwich Observatory, was examining old reports on solar observations. He found out that between 1645 and 1715, the sun in the northern hemisphere remained nearly spotless for 32 years. It was the severest phase of global cooling, which was called the Little Ice Age, the coldest period of modern human history. In Russian history, this time was marked by the invasion of the Swedish army, led by the King Charles XII. That war ended with a great battle near Ukrainian town Poltava. It's a fact that half of the Swedish army had died before the Battle of Poltava. The reason was the extraordinarily cold winter of 1708 and 1709. There is much evidence, including the diaries of Russian Tsar Peter I. Now, having performed a thorough research, we can say that it was the coldest winter in the last 300 years. Was it the absence of sunspots which caused the cold, or was it just a coincidence? The spots are the areas where magnetic field flux concentrates. What we call solar activity is just their presence or absence. There are charts which prove correlation between solar activity and climate change. Or, at least, they show that such correlation existed in the past. We can logically divide this scenario of solar activity on two periods. The first is the period of high solar activity. It started in 1957 when we started observations, and it lasts to the present day. We don't have much information about the low period. It ended in the 1930s. Then 1996 came. Until 2008 we received the data which showed us that all our calculations were wrong. The sun started to behave in a way which we hadn't expected. From 1997 to 2012, the researchers registered a strange phenomenon. Solar activity suddenly became low. It seemed that in some time, there will be no sunspots at all. The scientists all around the world were anxious about the news. They would say that if the magnetic field flux is getting weak in the shades of the spots, then we'll hit the Maunder minimum by 2025. Does it mean that we are approaching a new ice age rather than global warming? In 2012, solar activity and the magnetic field became normal, but the researchers found the contradiction between solar charge and weather observations. According to solar activity level, the planet will face cooling very soon, but the atmospheric air is heating, and the threat of global warming still grows. If there were no humans as the factor of climate change, we would be approaching a global cooling. But we are not. What we register is just the opposite. The weather is getting warmer every year at a rapid rate. In spite of the abnormally low solar activity, it gives us the right to state that human factor became the main reason of the global warming, starting from the middle of the 20th century. So, if humanity is the reason, can we compare its influence with natural factors? In 1998, a new term was introduced. Scientists called it hockey stick effect. That's how the diagrams of global temperatures and carbon dioxide emission look like. The diagram is relatively even with minor fluctuations, but it goes up steadily since the middle of the 20th century. It was the time when people started to take much bigger amounts of coal and oil. We started using them for power production. Thousands of plants and factories opened, oil consumption grew, carbon dioxide emissions broke all the records. The more CO2 that gets into the atmosphere, the warmer it gets. This is a basic physical law. You cannot argue with it. Today's level of carbon dioxide concentration is 401 part per million. That's 45% more than it was 250 years ago. There hasn't been anything of this kind in the last 3 million years. So we can say for sure that neither Homo sapiens nor his less skillful ancestors lived in the atmosphere with so much CO2 in it. Well, dinosaurs did live in a similar condition, and they seemed to like it. Back then, there was little oxygen in the atmosphere, but there were a lot of carbon dioxide and methane. At that period, the Earth was still forming. Volcanoes and the lava streams emitted more CO2 than all modern enterprises together. They turned our planet into a huge greenhouse where a man couldn't survive. What happened then? We all know. The planet got rid of excessive CO2 in a relatively short period. At the same time, it got rid of all dinosaurs. Are we the next species to become extinct? This happens because humanity became a space factor. The emissions of freon gas, CO2, all those cars and plants and factories, all these things contribute to global warming, and the climate becomes warmer. Although, according to solar observations, we were approaching a little ice age. They call it the butterfly effect. A minor event in the past results at big trouble in the future. How does it work? Greenhouse gases like water vapor, CO2, and methane work as glass windows. They hold the heat inside the atmosphere and don't let it go back to space. If the atmosphere didn't contain these gases at all, the difference between day and night temperatures would be almost 60 degrees. When factories and power plants all around the world started emitting carbon dioxide, it began to hold excessive heat in the atmosphere. Then it was like a chain reaction. The sun melted permafrost layers and a great amount of methane went out. Its greenhouse effect is 25 times bigger than that of CO2. What is more, the global ocean is vaporizing much more water. The researchers at the University of California analyzed the satellite records for the last 13 years. They found out that the circulation of water is getting 1.5% bigger every year. The excess of water doesn't spread equally around the planet. It's getting drier in arid regions, and there are more water in humid areas. People there suffer from downpours and heavy floods. Humanity should be very careful. Every action leads to a reaction. The atmosphere will clean out itself. It has so many mechanisms of self-defense. There are millions of ways to do it. But in any case, it's a complicated process. People need accurate long-period weather forecasts to survive the wrath of the heated-up planet. If we had them, we would have more time to evacuate people from the zone of a probable disaster. Farmers wouldn't plant in the areas of great flood risks. It seems that nowadays scientists are equipped well enough to do it. Every machine that is flying, rolling, or standing on the ground is equipped with various instrumentation. Every day, we receive about 10,000 data sheets from ground stations all over the world, and we get another 80 to 100,000 reports from airplanes. Satellites provide 250,000 reports. All that data is collected in the main facility of Russian Service for Hydrometeorology and Environmental Monitoring, where it's processed with a supercomputer. The machine estimates the risk of disasters and makes forecasts. So what's the result? We have thousands of observatories, satellites, and weather stations, but we still cannot make precise forecasts for more than a week. We still don't know where another hurricane is going to hit. Meteorologists call the wind a hurricane if its speed exceeds 35 meters per second. Now we can quite accurately predict the paths which hurricanes will follow in the next 2 to 3 days. August 28, 1978. Anatoly Dyakov sends a forecast to the North Atlantic, to the captain of Sergei Korolyov's ship. Storm weather, stronger west and northwest wind, waves 5 meters and higher. In September, 5 to 7, 24 to 28, and October from the 10th to the 17th, the 27th to the 28th. The heaviest storms are to be expected in the last decade of September and the first decade of October. Wind speed will mark at 35 meters per second, sea condition up to 80 B. On the 6th of November, the captain answers back. Your assumptions proved to be true. The dates of bad weather which you enlisted were exact. Let me thank you from all the crew. You did a great job. I can't help admiring it. He predicted the hurricane on the 28th of August, but it came there only on the 27th to 28th of October. How did he do it? It's not in a good condition. The house was on fire. Every year, he started a new journal. This is just one of them. There are dozens of journals, and each of them contains notes of thanks from all across the Soviet Union, as well as the requests for forecasts. Hundreds of letters from Belarus, Moscow, and the Urals. Here's another one, also from a captain. It came from New Scotland in the Atlantic Ocean. It says, "Thanks for your previous forecast. It was highly accurate." Long-period forecasts are the soft spot of modern meteorology. How can we adapt to the new climatic environment if we are so blind? Vladimir Panko, a researcher from Novosibirsk, considers himself the disciple of Anatoly Dyakov. He makes his own super long-term forecasts. Panko collects various data which is not limited to solar activity records. He considers the moon and the planets, which also affect the atmosphere. The sun and the moon affect the planet. Everybody knows that. But these are long-period components. They cause long waves in the atmosphere. We take all the factors and compare them to the real flow of processes on Earth. I call it the method of geocosmic correspondences. I invented it nearly 50 years ago, and from that time, keep on developing this method. It's difficult to develop observation methods when the research is not funded. The works of Russian weather prophets remain unacknowledged. It's odd because this field is profitable. American scientists say that if the preciseness of long-term forecasts increases by 5%, the net profit will equate to $18 billion per year. Novosibirsk, Nanomaterials Production and Application Laboratory, Borisov Institute of Catalysis. Here, the researchers have created and put into operation a unique technology which allows for turning associated petroleum gas into a monofuel consisting of pure methane.
The hydrocarbon mix goes into this catalyst element. The reactor is put into the oven. Now you can control the temperature. As you can see, you don't need to handle heavy things. I can cope with it easily.
The technology is effective at small oil fields. There are many of them, not only in Russia, but in other countries as well. Associated petroleum gas is difficult to transport for long distances. It's not profitable, as the nearest refining facility is always far away. The gas is burnt in flares, emitting tons of CO2 into the atmosphere. Now, small oil fields can become energy independent. They can produce methane from associated gas right on the field. Then it can be used as the fuel for all the machines which work there. We'll be able to cut down fuel consumption at least by twice. It means that CO2 emission will be reduced twice as well. The state controls this process. There is a special law demanding that all oil companies must dispose of 95% of all associated petroleum gas. This is possible only when you use modern technology. It doesn't need to be complicated. Our installation proves this principle. It's effective and very easy to use. In the neighboring lab of the Institute, they produce nanofibers from hydrocarbon materials. This fiber is only 100 nanometers thick. It's 1/10 of a micron. This production line is another example of hydrocarbon waste use. Nanofibers are used for the reinforcement of concrete and producing composites. A thin net made of carbon threads increases the strength and durability of products by 30 to 40%. Carbon is a unique material. You can create a great number of various materials out of it, and all of them will be different in properties. Here is just a single example, nanofibers. We also produce nanotubes, some special sorts of soot, technical carbon. All these can be used in tires production, for example, but generally there are many various ways of application. Carbon materials are used everywhere. There is another way of reducing greenhouse gas emissions, alternative energy sources. There are countries in the world, mostly small ones, which manage to fully substitute oil and coal for green energy solutions.
My country, Costa Rica, which is a small developing nation, has for many years had a very proactive policy with respect to the environment. It has understood that economics and the environment can both go together. So, for example, today, almost 100% of our energy base is all renewable energy, and it has made us much more competitive. A second example is the fact that we have set aside about 1/3 of our territory in national parks.
The world community came to a vitally important understanding. When the global warming reaches its climax, there are not going to be local disasters. It will be a global catastrophe. We see that there are no quiet and peaceful places on our planet where you could stay and survive, while the others are dying in the opposite part of the world. That is why this problem is common for all nations, and that is why we shouldn't consider only local risks and threats, thinking of a better climate situation in our country if compared to Pacific nations, for instance. Thinking this way would be a mistake. We don't know what our planet is planning for the future, but we can register changes in certain places where we live. The Laman Suo swamp remained unchanged for thousands of years.
What's happening with it now? We have a photograph of the swamp, which was shot 60 years ago. This place was an open field. Now we're standing in the woods.
The swamp gets lost in the thick forest. The more trees are around, the less methane is produced. It means that the threat of global warming is reduced. Nature finds the ways to heal itself. The Earth is a high-endurance planet. It has traveled a long way in space. We are the passengers of this ship. and we must do everything for this travel to last longer.